All right, so we're at example 29, and example 29 says, find the equation of the tangent, it says find the equation of the tangent to the curve y is equal to e to the x cos x at x is equal to 0. Now, essentially, the procedure for doing this.
Good afternoon.
Good afternoon. Essentially, the procedure for doing this is that in order for us to determine the equation of the tangent, we need two things. We need the gradient of the tangent and we need the coordinate of one point on the tangent. Now, the gradient of the curve is equal to the gradient of the tangent at the point of contact. So the first thing, I could either start by finding the gradient or start by finding the point of contact. So let me start by finding the point of contact. Point of contact. Now this is where the tangent touches the curve. I have the x coordinate already, so I need to find the y coordinate. I'm going to say when x is equal to 0, y would be e to the 0, the cosine of 0. Now, the cosine of 0 is positive 1, and e to the 0 is 1. So this is 1 multiplied by 1, which is 1. So the point of contact is x is 0 and y is 1. That's the point of contact. Now, the point of contact is where the tangent touches the curve. So the point of contact is a point that is both on the tangent and on the curve. The two things share the same point. Next, I'm going to find the gradient of the curve, which is equal to the gradient of the tangent. I have y is equal to e to the x cosine x. Now I'm going to differentiate. This is a product differentiation. So dy by dx. Now product differentiation, as a reminder, if y is equal to u times v, dy by dx would be equal to u dv by dx plus v du by dx. In other words, leave the first, differentiate the second, plus leave the second, differentiate the first. So I'm going to leave the first, e to the x, differentiate the second. When I differentiate cosine x, I'm going to get minus sine x. So this is minus sine x, plus leave the second, which is cosine x, differentiate the first, which is e to the x. When you differentiate e to the x, you're going to get back e to the x. So this is e to the x cosine x. And here, what I did was I leave the second. The second is cosine x. I left it. I didn't do anything to it. I differentiate the first, which is e to the x. And when you differentiate e to the x, what you're going to get back is e to the x. So dy by dx is equal to minus e to the x sine x plus e to the x cosine x. I need to find the gradient when x is 0. So when x is 0, dy by dx would be equal to minus e to the 0, the sine of 0, plus e to the 0, the the cosine of 0. The cosine of 0 is 1, e to the 0 is 1. The sine of 0, this should have been 0. The sine of 0 is 0. So the left part is going to come out to be 0. And dy by dx, when x is equal to 1, dy by dx is equal to 1. So now I have enough information to find the tangent. So I'm going to go tangent. That's what I'm finding now. The formula for the equation of a straight line is y is equal to m into x minus x naught plus y naught. The input for this formula is m, the gradient, which we just found out to be 1, and the point of contact, which is 0, 1. 0, 1. So let's put in our values. So y is equal to m, which is 1, into x minus x naught, which is 0, plus y naught, which is 1. So distributive law, 1 times x is x, and plus 1 at the end. The tangent is y is equal to x plus 1. The tangent is y is equal to x plus 1. All right, guys, you can take it in. We did a number of them last class. I don't see us making any mistake. I don't think we did. So the tangent is y is equal to x plus 1. Y is equal to x plus 1 is the tangent. The general procedure, I could find the point of contact by substituting the value we get for x into the function for y. So that will give us the y value. Once you have the x and y value of the point of contact, then I need to find the gradient function, because the gradient of the curve is equal to the gradient of the tangent at the point of contact. So once I have the point of contact and the gradient of the curve, which is equal to the gradient of the tangent, I put that in my formula for determining the equation of a straight line. Once I put that in, I'll get the equation of the tangent. And so that would be the end of, then the homework that follow would be exercise 2C.